Okay, section 2 of this examination. Electric blender has a massive 1.25 kilograms. What is its weight? This is a really simple question. All they're asking you is, they're just checking to see that you understand the difference between weight and mass. Okay, so normally when people say, what do you weigh? You give it an answer in kilograms. In the physics world, in the engineering world, that is incorrect. Weight is a force. So you take your mass and you multiply it by the gravitational acceleration. And for this course, we say it's 10 meters per second squared. G equals 10 meters per second squared. In physics, you actually say it's 9.8, I'm pretty sure. But we say 10 times 1.25. You move your decimal place one position to the right, and we end up with 12.5 newtons. Easy mark given you there. Or 2 marks, sorry. This one here, name and sketch 3 types of forces. So over here I've done a little sketch here of a block being dragged this way. I probably should have had an M written in there to show that this has a certain mass, and the frictional force on the surface. So frictional force, a weight force, so we have this massive weight of 100 newtons, which is a 10 kilo mass hanging on a rope, and then reaction force. So we have the weight force acting into the plane and the reaction force normal to it. Reaction forces are always normal to the plane. Weight forces always go directly down. Here, all engineering and architectural drawings are governed by standards. List 4 drawing features that are covered by AS 1100. So you need to go back to your drawing resources and do a bit of study on that. Oh, by the way, with the types of forces, I also said you could have said things like applied force, centrifugal force, gravitational force, magnetic force, electrostatic force. So there's lots of forces that you could have listed, but that would be the easy ones to list. But if you needed more, there's some more down here. Okay, so AS 1100 governs the type of scale that's used in drawings, the lines, outlines plus dimension lines, title block features, and also the type of projection. So for orthographic projection, for AS 1100, we always use third angle projection, whereas in Europe they use first angle. This is described 3 primary bonds. This is work from your chemistry courses as well. Ionic is a strong bond usually between a metal and a non-metal, swapping of electrons creating positive and negative ions, and I've written here that they're normally insulators. Covalent bonds tend to happen between non-metals rather than a metal and a non-metal, and they result from the sharing of electrons and then a conductor. So in a metal, your valency electrons are usually quite a distance away from the nucleus, and they're free to flow because of that, and they flow almost like glue around the positive ions of the metal. So that's what makes electrons very good conductors of both heat and electricity. So you need to think about these types of bonds and what properties they give to the particular substance. Differentiate between a thermoset and a thermoplastic. Give one example of each. So thermosets are the ones that once you form them into the shape you want, you're not going to be able to get them to change back if you heat them up again. They'll just burn rather than go soft again. And they have strong covalent bonds along and between the chains. So once they set, they cannot be remelted. And epoxy resins, vinyl ester resins, and polyester resins are examples of that particular thermoset type of plastic. And the thermoplastics are the ones that you can remelt. And they have weak secondary bonds between the covalently bonded chains. So your polymer chains are strong, they have covalent bonds, but then between those chains you've got soft secondary bonds, which are actually van der Waals forces normally. And examples are polycarbonate, ABS, and polyethylene. It might be a good idea to learn 3 examples of each, and how those bonds happen, how thermoset differs to thermoplastics and why. If you tell yourself a little story about why one can be melted because it doesn't have the cross bonds, the strong cross bonds, and maybe the diagram that's in the textbook is also useful for that. Briefly describe ceramic materials. Well, ceramic materials are materials that have good thermal and electrical insulation properties. So they're insulators both for electricity and for heat. You can normally put them into high temperature situations and they remain stable. So that's why they're quite often used for kilns and refractories and things like that where high temperatures are involved. and they're chemically resistant as well. They tend not to react to chemicals, so they're a good thing to put in a very nasty, hot, toxic environment. For this table here, this is page 21 of your textbook. You really need to have a good look at that. Each one of these types of processes is either usually fusion or pressure, and you've got to fill this table out. So metal inert gas is a fusion process. Aluminium is one of the things that you can weld with MIG welder. Oxyacetylene joining thin metal sheets is fusion. Spot welding is when you're putting together two metal sheets and there's two little probes that push down and create pressure to weld the joint. And then seam welding, well, if you think about a pipe gets rolled and you've got a seam along one side, and once again that's a pressure process. So we've got to really have a good look at that table and get our heads around it to be able to answer that type of question. It's a lot of information, I know, but that's just what's got to happen. Polymers are formed by linking together smaller molecules called monomers. Name two different ways in which polymers can link. We talked about this and it's in the textbook on pages 24 and 25. So we have addition polymerization. So you've got identical monomers joining together under heat, pressure, or a catalyst, which is a catalyst is something that speeds up a reaction. And they link to form a polymer. Or you've got copolymerization, which is just the same as above, but the monomers are different. And then a third type of polymerization is condensation polymerization, where monomers join to form polymer and a byproduct. Now, they talked about copolymerization as a type of addition of polymerization. So I don't know whether you can actually say that those two are different as such. They're both additions, types of addition polymerization, but one, when you're talking about copolymerization, you've got different monomers. So I think if you want to talk about two processes, you might want to talk about addition polymerization, which is forming either a copolymer or an addition polymer, and then condensation polymerization as being the separate one. But they don't really make that very clear in the textbook. And here's some pictures of this is addition polymerization, where each monomer is the same, and this is copolymerization, where each monomer is different. Over here we have some of the more difficult questions for this examination. So what I might do is I'll do a couple more questions and then I'll do a separate video. We'll do this next question and then we'll do another video. This is adding two forces graphically. So all you need to do is take this 50 newtons and move its tail up to the head of this 40 newtons, and then you just draw a resultant. Now if you measure that resultant, I've said that for this drawing that 1 centimeter equals 10 newtons because you've got a 4 centimeter and a 5 centimeter line. So once you've done that, once you measure your resultant, you get 7.5 centimeters, and when you multiply by the scale of 10, you end up with 75 newtons. And if you measure this angle that's inside here, it works out to 37 degrees. Now I did do an analytical analysis of that, but you really don't need to do that. All you need to do is take your protractor and measure this angle between this 40 newtons and the FR, and that's 37 degrees. And that gives you a value and a direction, which is what you need for a vector. And that's it for this video, and we'll do 20 on the next one.